So like I said, this lesson is not so long. There's just really one basic idea I want to cover in it, the vector triangle. So write down the title. The vector triangle. So you know what a vector is, and you know what a triangle is. Yeah. So we're going to look at the vector triangle. Okay. So we can add vectors together. Yeah. This is allowed. We can add vectors together using a vector triangle. So if I have two vectors A and B, in fact, let me actually draw it over here. So I have, for example, here is vector A, and maybe here is vector B. How do I add these together to make a new vector? In other words, my question is, how do I do this, A plus B?
We can add the value coordinates like...
There's no coordinates yet, just pictures. Does anyone actually know how to add them together? Have you seen it before?
Yes.
Yeah? So how do you add them together?
Yes.
That's okay. Anyone else who remembers?
Magic.
Not quite that. That explanation will do in a subject like biology, but it wouldn't work in a subject like physics.
We can start the B from the A.
Yeah, this is the idea. So you have to connect them like a path. You put the B together with the A. So let me show you that. And by the way, that's important, very important vocabulary. When you add two vectors together, the answer is called the resultant vector. And this is what the diagram looks like. So you put the B at the end of the A, and the answer is the long side. So A, B, you put them together, and that's the answer. So please draw this, and please write down that word, resultant vector. You wrote down, you drew that picture?
Yeah.
Very nice. And did you write down? Oh no, you didn't. Write down that, see that word in red? If it's in red, it means it's very important. The resultant vector is the answer. That's what it's called. So if I ask you for the resultant vector, what am I asking you to do? To add the vectors together. Resultant is an adjective, resultant vector. What's the noun? Resultant? You see resultant?
Yeah.
That's an adjective. Result is the noun.
Yeah. I have understood.
You know what word result?
Yeah.
You don't know this word?
Yeah.
Do you know the word result? R-E-S-U-L-T. You know this word? What's another word for result?
Outcome.
One word. Give me one word that means result. Another word.
Outcome.
Oh, simpler word. Answer.
Yeah.
Result means answer, really. So it's like saying the answer vector, resultant vector. Yeah. I really, really, really want you to know this word because it's used frequently in the exam. And then students in the exam saying, Stephen, what's resultant mean? I'm like, I can't tell you. I can't tell you. So this is an important word. Resultant vector. It means the answer. You add them two together, and then this is the answer, the result. The resultant vector. Okay. So we know how to add vectors together. We make the triangle. Okay? We can also multiply a vector by a scalar. So for example, when I multiply a vector by a number, such as 2, what do you think happens to the vector? If I multiply a vector by 2, what happens to the vector? What do you think? It increases.
Yeah.
How much? Twice as big. Yeah? So we have...
Try the coordinates.
Well, no coordinates yet. No coordinates yet. If I multiply by 2, I will double the length. And what if I multiply by a half?
Half.
Yeah, half. The length is half. The half in length. And interestingly, if I multiply the vector by -1, look, if I multiply it by -1, the vector gets turned around, changes direction. So this is A, and then this is minus A. Yeah. Does that make sense? So this is A, this is minus A. Yeah. And if this is A, then this is 2A. And this is a half A. Okay. So just make note that you can multiply a vector by a scalar and it makes it bigger or smaller. So make some notes like this, please. Whatever way you want to write it, I have no problem with. So make some notes. Did you write some notes like this? Yeah? Or if you want, you can even draw it. If you want to draw it, so you can have like A, 2A, and half A. You could draw examples.
Multiply vector by solid from, -1.
Yeah, it flips it around.
How flips it around?
Yeah.
I know you can understand.
Huh? Yeah, but you'll have to remember. You don't need to write my words down. I'm not a great writer, okay? Whatever helps you to remember your notes for revision, I mean. Can I go on?
Yeah.
No, but see, I think it's great that you think what I write is so important you want to copy it. But it's fine just to make your own sentence. It's a lot to write down for a small idea. Yeah. You know what I'm saying? You don't have to write all of this down, just your own note in English. Okay, I'm going to continue. Yes? No. I can continue? Yeah? Yeah, okay. So, you know you can add, subtract, multiply and divide scalars. You learned how to do this in elementary school. You know how to do this. And you know how to multiply a vector by a scalar. So if you multiply a vector by 2, what happens? Twice as big. If you divide by 2, half the length. We can add vectors. What do we use to add vectors? The vector triangle. Yeah? Whoops. But this is the key point. We cannot multiply vectors. We can't multiply vectors. Well, not really. So, for physics, we shall say for now and for the rest of the course, we cannot multiply vectors. But in that class, we will see a way to kind of multiply vectors. But really, for physics, we're saying we can't multiply vectors, and, no surprise then, I'm also saying we can't divide vectors. So we can add vectors, or subtract vectors, but we can't multiply or divide them. So, you know, if this is vector A, and this is vector B, I can add them, but I can't multiply them. That doesn't really mean anything.
I cannot divide.
And you can't divide them also.
Add
and subtract is all you can do with vectors. You can multiply a vector by a number, but not by another vector. So just to make some note that you are not allowed to multiply, or divide a vector by another vector. It is forbidden in physics, not in maths. Okay. So that's just a little bit about what we can't do. Oops. So let's look at some examples here. So I have two vectors, 5 kilometers per hour east and 5 kilometers north. You see those two vectors? A and B. So let me just draw them. So this is, for example, A. This is A, and this is 5 kilometers per hour. Is that what I said? And then what did I say B was? 5 kilometers north. So here is B, and this is 5 kilometers north. Okay, so my first question is, draw these vectors. Well, I've just done that. So I've already drawn them. Can I add these vectors together?
Yes.
No.
Because one has speed.
Yeah, in other words, I can't add them together because they're different units.
Yeah.
The first vector is 5 kilometers per hour, and the second vector is 5 kilometers. So in fact, you can't add them. This is a problem, a mistake a lot of students make. They think any vectors you can add together because you just use your vector triangle. No, it's still like what you learned in the first lesson. They must be the same unit, so before you can add them together. Okay, so just be careful about that. So the answer here is no. The units are different. Okay. So, I want the vector TB. What is the dimension of TB? And T is 2 hours. So here, T equals 2 hours. And I want to know what is TB. Yeah, TB. And you know what? I think I just screwed something up here. I did screw it up. Sorry. There's a mistake in my question. I meant to put the per hours on the B. So please make that change. The unit is the wrong way around. I want the B to be kilometers per hour. Okay, so please make that change. Okay, so still, what is the unit of TB? What's the unit of TB? Kilometers, isn't it? Because what's the unit of T? It's hours. And what's the unit of B? Kilometers per hour. So the answer is kilometers. Okay. So can I add A and TB? Am I allowed to add these now? Yeah, because they're both what to say, km, kilometers. I think that's what I asked next. Yeah. No, well, first I asked you to draw TB, so actually we'll do that first. Okay, so what's the difference between B? Here's B again. Let me go down a bit. Here's B, and that's 5 kilometers per hour. And then what about TB? What would TB look like? How is TB different?
Kilometers longer.
How much longer?
2 times longer.
Yeah, twice, because of the 2 on the T. So TB is going to look like this. It'll actually be 10 kilometers per hour, because remember the T... Oh, sorry, thank you, there's no per hour. Long day. Right, 10 kilometers. Okay, I think my next question now is to add them together. Can I add them together? No, I can't, because they're both km. So I can now do the next part, E, which is A plus TB. Please remind me, what did I say A was? 5 kilometers east, was it? So I have here 5 kilometers east, and then I have 10 kilometers north, and don't forget I'm using my triangle here. So what's the answer when I add them together? It's actually, can you see? This is the answer.
Yeah.
This is the resultant. Okay?
We do sometimes a resultant.
Yep, when we get to force. Do I ask anything else? Ah, my last question. Yep. What does this represent, do you think? Yeah, what would it mean? So, like, for example, if you think about it, what was the unit of A? Kilometers. And what was the unit of B? Yeah, so A is like a position, and B is like a speed, isn't it? Because it's kilometers per hour. So if I add these together, what do you think it's like that has happened?
Speed.
Yeah.
It's speed. This is like
If I don't expect anyone to get this, I'm just wondering if anyone knows. No, I'll tell you, look. This here is A, and this here is TB. So it's like, here is the person at A. What's his name? He is called Origin. And it's like, here is some other person here. And they start at A, but then they are moving north with a speed of 5 kilometers per hour. Think about it. If you move for 5 kilometers per hour, after 2 hours, how far have you moved? 10. So if he's 5 here, and then he moves 10 north, then he finishes here. I'm just trying to show you, why vectors are important, because later we will see that they are used for movement. But don't worry just yet, okay? Just a sneak preview. The answer is, I would say, a man at A moving north at 5 kilometers per hour for 2 hours. Okay, I'll go back to the slides. No, don't even bother writing that down. I just want you thinking, that's all. Okay, another example. Now we have one with an actual man. So a man walked 5 steps north, then 5 steps west, then 1 step east and 1 step south. So just write down the steps he took. 5 north, 5 west, 1 east and 1 south. Just write those 4 down, please. 5 north, 5 west, 1 east, 1 south.
5 north, 5 east, west.
This took 9 seconds.
And it took 9 seconds to do.
Okay.
You got that? I just need you to write the numbers. Yeah? And the time is 9 seconds. So the first question is, what is his speed? So I gave you the formula in the last class. What is the formula for speed? Yeah?
This is order.
That's velocity. Speed is distance over time. Yeah? So, what is his distance traveled?
12 steps.
12 steps. So the distance is 12. And what's the time? 9. So let's have a look here. Where's my... I can't see. A, sorry.
4, 3.
So the distance, we'll write them out. What was it? 5 steps plus 5 steps plus 1 step plus 1 step. That is 12 steps. And the time, I said, was 9 seconds, wasn't it?
Yeah.
So the speed is the distance over the time which is 12 steps over 9 seconds, which is 1.3, I believe. Yeah, 1.33 steps steps per second.
Okay, not 4 over 3.
Yeah, that's fine. So that's his speed. He walks at 1.33 steps per second. That's his speed. Okay? Next question. Draw the 4 velocity vectors. So northwest, east, south. Okay. Whoops, that's no good. And we go back. I want to go back to pen. Oh my goodness. I think I need to buy a new laptop. This one's dying. Where's pen? Maybe. Oh, pen. Okay. Right, B.
Draw these vectors.
Yeah, there's 4 vectors to draw.
5.
Can. I think this is not light enough, is the big problem. There we go. Right. Oh man, come on. Alright, I'll have to use the mouse. This is going to look ugly. B. Yeah, I told you it's going to look ugly. You know what? You'll just have to live with it for a moment, unless this comes back. No, not right now.
Do it by ourselves.
Yeah, well, I guess the next one is kind of easy. What's the first vector?
5 north.
5 north, so it'll be 5 straight up.
Yeah.
Next one?
5 west.
5 west, so that's 5
Left.
to the left, and then next is
1
1 to the right, and then lastly is 1 south. Now what I want you to do is I want you to draw them, but I want you to put, I want you to put them head to tail. So for example, give me that pen, give me a pen. So the first one is 5 north, isn't it?
Yeah.
And the next one is 5 west. So then I want you to draw your vector here, because that's what the man did. He went this way, and then he went this way, and then what's the next one?
1
East. So then there's 1 to the right, and then lastly
1 south.
1 south.
Yeah.
Okay.
So the resultant, I want you to, well, first I want you to draw those 4. So do that first.
1 east, then you move back south.
Yeah, I can go back to the question. You know what? I'll just draw them on the board.
Write the question up.
Yeah, I'll just draw them over here.
Am I going to try and actually write the question down? Or no?
Yeah, I'll leave it there for you to write down now if you want. Draw the 4 velocity vectors. Yeah, so the first one, 5 north.
No.
And then the next one is 5 west. So this is 5 steps, 5 steps. And then 1 east, so it goes backwards like this, and then 1 south. Yeah. They are his speeds. He walks 5 this way, 5 this way, 1 to the right, 1 down. So, yeah. Now, the next one is a little bit different. I want the 4 displacement vectors. So what does displacement mean? What's displacement?
Same as the
What's another word for displacement? Position. So at the beginning, I suppose the man, well, I suppose really, at the beginning he's just here.
Yeah.
So there's no displacement. Then, after 5 steps, he is
Up there.
here. Then, after another 5 steps, it's like this. Look here carefully. That's the first one.
Yes.
This is the next one, isn't it? When you add these together, he's here.
Yes.
And then after this, he's now here. And then finally, the last displacement vector, he finishes here.
Yes.
Oh.
So this is the one we really care about the most because this is where he finishes. So he starts here and he ends here. So it's like first he's here, then he's here, then he's here, then he's here.
Displacement vector, that's right.
It would be, yeah.
If in the question they said draw the displacement vector, then only we have to draw the last one.
Yeah, if they said in the singular, draw the displacement vector, you would draw the last one. But because here it's plural, the displacement vectors, I want to see his movement. So the S is important. And also Fahad, because I said 4 as well.
Whoa.
Now, I want to give you 1 or 2 minutes first to try and do D by yourself. So what I want to know, look, I want to know what is the magnitude. What does magnitude mean? It means like the size and the direction of the last displacement vector. Tell me the magnitude and direction of this vector. So I want you to try, then I'll do it. So please try. D.
Resultant slope
What do you mean, resultant what?
of the...
Resultant magnitude? No.
Draw
Now don't worry if you can't get it, I just wanted to try first. Let me just make a bit more space here. We're back. It's good. Okay, I'll do the D part now. Let me help you with it. I'll give you a little hint. I think it's helpful if we have some boxes to go with. So, the man starts here. Then he is 1, 2, 3, 4, 5. He is here. Then he goes 1, 2, 3, 4, 5 here. Then he goes 1 here, and then 1 here. So in red, what I want you to see, what I hope you can see, is that the same as going 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, yeah. That's this one here. Now we know this. Oh dear. That's here. But I hope you can see the direction, because this, if you look at it like a triangle,
it's almost 45.
well, it is exactly 45. Because this is 1, 2, 3, 4 units, and this side is 1, 2, 3, 4 units. So this here is actually exactly 45, which means this is exactly northwest. Perfectly.
And the magnitude.
Now this is the difficult part. What is the magnitude though? It's not 8.
10.
It's not 10. It's not 6.
2.
There you go, 2.
4.5.
We might be getting closer.
It's 9.
Nope. Nope.
8.
200.
The answer, think about it like this. If you want, you can think about it like a triangle.
Yeah.
We know that this is 4 and this is 4. So if we use Pythagoras, you know Pythagoras? Yeah?
Half.
4 squared plus 4 squared equals, we'll call this here x, equals x squared. Yeah, so this will be root 32 is the x, which is about 5.6, is it?
Yeah, I got it. 5.6.
Don't recall me saying that. Whatever, root 32 is, roughly. Let's see. I think this in a moment. Yeah. The science students were in here beforehand. I want to freshen the room up. Science students, you know. Okay. Last part is what is the magnitude and direction? What was his average velocity? Can I have a calculator, please? Actually, here.
Is average velocity. Average.
Yeah, but don't worry too much about the word average. That's why I put it in brackets.
So it means,
Well, what is velocity? It is direction, speed and direction. Or what's the formula I gave you? Displacement over time. So think about it like this. He starts here and he finishes here. Yes? How long does it take him to do that?
9 seconds.
9 seconds, isn't it? Yeah? So, you can think about it like this. On average, it's like he's just doing this. Slowly going across here, and this takes 9 seconds. Right?
Yeah.
Now, of course, he's not doing this. What is he doing? He's going up, across, down. But it's like, that's why I put, average in brackets. It's like he's doing this, but it's taken him 9 seconds to do. So this is 5.66 steps.
Divided by 9.
So I'll divide it by 9. So I'm saying it's like he's doing 0.629 steps per second north-west. That's his velocity vector. Now that one was a little bit difficult, I know. So you can test this out if you think about it. If you do this for 9 seconds, if you travel at this speed for 9 seconds northwest, you will go from here to here, the same as the man. So this is like an average. Which seems that, you know averages with numbers, like if you have the average of, for example, if you have the average of 3 numbers, what do? You add 3 numbers and you divide by 3. So they're actually almost the same for vectors. If I have 1, 2, 3, 4 vectors, what's the average of 4 vectors? You add the 4 vectors together, like I did here, but I don't divide by 4, I divide by 9, because 9 is the total time. So the only difference is we divide by the total time, not how many vectors I have. But I want you to see how it's similar to averages in maths. So if I have 4 numbers, I add them and divide by 4. If I have 4 vectors, I add them and divide by the time, in this example. This question was, a question like this was in the exam. Okay, so we're starting to look at what you might get in the exam as a question. Okay. This was yours. You can't be that cold. Are you that cold? Really?
No.
See, I'm thinking maybe I should close the window, or maybe I should leave it open so it can toughen you up. What do you think is the better of the two options? We'll go for the tough option. I like it. Okay, next slide. So the only other point I want to say about vectors, which is important, is that they're commutative. In other words, A plus B is the same as B plus A. So when you draw your vector triangle, it doesn't matter which way around the sides are, you get the same answer. So please note A plus B is the same as B plus A. So like here, this is A, this is B, and this is A plus B. And here, for example, this is B, this is A, and you can see the answer is actually the same, A plus B. It's the same answer. Is this vector the same length? Yes. And is it in the same direction? Yes. Yeah. So A plus B equals B plus B.
Yeah, you can do.
Yeah, well, I know that. Now you know it too. Yeah, so 5 minutes, you should at least write them down, and maybe you can even do some of them, because the first one is just, I ask you to draw.
Just homework.
What do you feel the answer is?
Yeah.
Correct. So write these down. Yep. But I'll give you 5 minutes now. So if you do some of them now, that's good.